Hello students. Uh, Today we'll be continuing with the next section of Unit 4, which is three-phase induction machines. In the previous lecture, we have discussed about the what are the various methods. Means we have talked about the starting methods of induction machine. What are the different things we have a bit. It was a quick revision, you can say. But now in today's lecture, we'll be talking about the constructional features of an induction machine. What are the different types of machines, and what are the constructional features of that? So, as I've already told you, that induction machine basically there are two types of induction machines. You can say three-phase induction machines, and those depends on the type of rotor structure that is being used. In stator structure is always the same. Means stator will carry three-phase winding, balanced three-phase winding, which is basically 120-degree display phase displaced with respect to each other, and rotor, depending on the structure of what kind of rotor you are using. There are two induction machines. Number one, as this is mentioned over here, one second. Number one is a squirrel cage type. Squirrel cage, or you can also say it is a cylindrical type induction machine. Number two is slip ring or wound rotor type induction machines. Now they say that generally almost here it is written almost 90%, almost 90% of the three-phase induction motors are of squirrel cage type. And you can say that it's also means almost 100% of single phase induction motors are of squirrel cage type. Now there are various reasons why this is much preferred over the slip ring or wound rotor. We'll be talking about that also, but initially I'll start with this slip ring type. Then I'll cover this squirrel cage type. We'll start with this slip ring or wound rotor type of induction motor. So I'll directly go to the slip ring type. See this one, slip ring wound rotor, slip ring type of induction motor. Now, what is there in this type of induction motor? As I've already told you that the structure of stator is same in both. Whether we talk about squirrel cage type induction motor or slip ring type induction motor, stator structure is same. It consists of three-phase balanced winding, 120-degree displaced, spatially displaced. Yeah. Now, when we talk about slip ring rotor, its rotor again consists of again balanced three-phase balanced winding, spatially displaced by 120-degree displacement, and the number of poles which this rotor will contain depends on the number of poles which stator will. I mean, suppose if you talk about an induction slip ring induction motor, and suppose my stator winding is so designed that four poles are being created on the stator, then on rotor winding, three-phase rotor winding will also be designed in such a way that four poles, whenever current flows through that winding, through that rotor winding, then four poles are created in that rotor also. Why? Because we know that the very important condition for developing a constant electromagnetic torque is that the number of stator poles must be equal to the number of rotor poles. So now we need to design that three-phase rotor winding in such a way that it will contain as many poles as there are present on the stator. Suppose my stator was carrying four poles, and I've designed my winding of stator accordingly so that it carries four poles. Now I've also designed my rotor three-phase winding accordingly, and I've put it in different slots accordingly so that it creates four poles. So it is a balanced condition, means four stator poles and four rotor poles. Now suddenly, by through some means, if I change the number of stator poles, earlier it was four poles, now suppose I'm changing the number of stator poles to suppose two poles. Now I'm changing the winding, I'm changing the stator winding to say two poles, and the rotor winding is kept intact. Okay, so now my stator poles are 2 and my rotor poles are 4. So now this machine will not run. Why? Because we know that the essential condition number two is not fulfilled. That is, the number of stator poles is not equal to the number of rotor poles. Now, to run this type of machine, again we need to change the rotor winding also. We need to change the rotor winding also and make it design it in such a way that it also contains 2 poles. It also creates 2 poles. Well, this problem, sorry, this is the problem in slip ring motor. Well, this is not the problem in squirrel cage. When we'll discuss that thing, we'll see that in squirrel cage, the rotor develops automatically the number of poles which are equal to the stator poles. It will always, rotor poles will always be equal to the stator pole automatically. Suppose if stator poles are 4, then rotor will automatically develop 4 pole. No need to change the winding and all those things. No need to change anything. If we change the stator pole to say 2, then rotor poles will automatically change to 2. How? We'll see over when we'll discuss about squirrel cage. But this is the advantage of using squirrel cage. But in slip ring, this is not so. Means again, if we change the stator poles, then we have to we need to again redesign that winding so that it creates equal number of poles as those are present on the stator. Also, since I've told that the rotor, in case of slip ring rotor, the rotor consists of balanced 3-phase supply. Okay, I mean balanced 3-phase winding. Now, for designing these windings, for arranging these windings in putting these windings in different slots, we need to we need an expert for designing them so that it creates equal number of poles as is required by the stator. So this is the problem. We need an expert for designing, for constructing, for designing such type of machine. Again, there is also maintenance problem in this thing. In this thing, you will see that this is known as slip ring wound rotor. We use slip ring brush arrangement in these types of motor. So again, there is a problem like maintenance problem. So if these many things are means these many things are not correct for such type of motor, then why are we using this? What is the need to use this? There must be some need, that's why we are studying this thing now. So yes, of course there is a need. What is it? That this type of motor, this type of slip ring or wound rotor arrangement provides us a mean to add external resistance in the rotor winding. This is very important point. You must be very careful about this thing, that it provides a mean to add external resistance in rotor winding. Externally, we can add resistance in rotor winding. This is not the case with squirrel cage. You will see. Now, what is the advantage of adding this external resistance? You will see the advantage of adding external resistance is that you will get improved starting torque. Your starting torque will be very much improved. You can also start your induction motor with rated voltage. Starting current is reduced. So these are the advantages of using these are the advantages of adding external resistance in the rotor, which is only possible in this slip ring induction motor. So wherever you require higher starting torque, you prefer this slip ring wound rotor type induction motor. Okay, so this is why we used to prefer these. Wherever you require a high starting torque, so these types of machines will be preferred. Now, what is written in these types of machine? That rotor contains. You can see, you can look at this arrow, and see there are 3 terminals. Obviously, I'll show you once again. I'll show you this thing. This is the case. See, this is three-phase supply. This is given to a stator. Okay. Now this is a rotor. You can see again a 3-phase winding is present on the rotor structure also. Now this is a slip ring brush arrangement. See, these are the 3 terminals, number 1, 2 and number 3. These are the three terminals which are coming out of the rotor windings, three-phase rotor windings. Now to these three terminals we are adding this slip ring brush arrangement, and in this we are adding this external resistance. Look at this. Look at these arrows. External resistance in each phase. This phase, this phase, and this phase. This is how we are adding this external resistance. See, this is the diagram. This thing. This is the rotor three-phase winding, and now we are adding external resistance in each phase. Now, why do we need this slip ring brush arrangement for adding this external resistance? Because we know that you must have studied these things in while you are studying your DC machine, your electrical machine part 1, that you need this slip ring arrangement. Why? Because these three terminals, these three rotor terminals which are coming out are rotating. Why? Because this rotor is rotating, so these three terminals will also be rotating. Now to add an external resistance to this rotating rotor will create a chaos. This is just not possible. I mean, it is possible, but it is very there are a lot of difficulties in doing this thing, and it is not easy to maintain as well. So what we do is that we'll add a slip ring arrangement. 3 slip rings are provided, and this brush is stationary. Now we'll add these external resistance. We'll take out 3 terminals, 1, terminal 2, and then terminal 3, and we'll add these external resistance to these stationary brushes. Through these brushes, now these external resistance are added to these brushes, and now this is terminal number 1, this is terminal number 2, and this is terminal number 3. Now we are getting 3 stationary terminals. Okay, earlier these terminals were rotating, but now by using this slip ring brush arrangement, we are getting 3 stationary terminals, and we are able to add these external resistance in this. So this is how this is done, and why this is known as external resistance. These external resistance are sometimes also called as starting or control resistance. Why? Because as I've already told you that this controls your starting torque, it improves your starting torque, and also during starting, these external resistance are basically added at the time of starting only, because at the time of starting a huge current flows in an induction machine, which may create a lot of problem, which we'll discuss while we discuss about the starting of induction machine. We'll discuss in depth. But the thing is that for avoiding that huge current, we add this external resistance, which will obviously reduce the current and will improve our starting of an induction machine, and also it will lead to higher starting torque, which is very essential. But during running condition, what we'll do is that we'll short circuit these 3 terminals during running condition. So during running condition, both slip ring and squirrel cage induction motor are one and the same thing, because now during running condition we'll short these 3 terminals, we'll short circuit these 3 terminals, so that these resistance, the effect of these resistance will vanish. This is what is written in this thing. With external resistance added through brushes, the motor is started. As it reaches the rated speed, the brushes are slide down, and the 3 slip rings are short circuited through a metal collar arrangement. Under running condition, it is similar to a squirrel cage type. So you got the point. Under running condition, it is similar. It is so why do we use it? We just use it so that, one second. So why do we use it? So that we can get higher starting torque and we can improve the starting of the induction machine. Okay, now we'll go to second type of induction machine, second type of rotor structure that is used in induction machine, and that is squirrel cage type induction machine. This is now, as I've already told you, that almost 90% of the induction machines are squirrel cage type because of its simple and rugged construction, means mechanically very strong. We'll see how. This is the diagram of your squirrel cage induction machine. This is very simple diagram, straightforward. Now you can see that this is the rotor structure of your squirrel cage induction motor. In your slip ring induction motor, the rotor was carrying a three-phase balanced winding. But now in your squirrel cage induction motor, rotor is carrying this cylindrical structure. Now these are aluminum bars which are put inside these slots, aluminum bars, and these rings, these are end rings which are used to short circuit these aluminum bars, or aluminum or copper bars, you can say aluminum or copper bars. So now these are end rings, brazed end rings, which are used to short circuit these bars, like this thing. These are the conductors, rotor conductors, this thing. So these end rings basically short circuit all the conductors. So this is the structure of your this. See what is the difference between the structure used in slip ring and this? That in slip ring you are having three-phase balanced winding, but in this case you are just having aluminum or copper bars which are short circuited through end rings. Now the major advantage of using this thing, now there is no requirement of any slip rings and brush arrangement and all these things. The extra adding of external resistance is also not possible in this case. Because why because in that slip ring induction motor we were able to add external resistance because we were getting three different terminals out of there, and we were able to add through slip ring arrangement. But this is not the case over here. So no slip ring arrangement. So if slip ring brush arrangement is not there, then obviously there is low maintenance. Also this structure is mechanically very strong and very, there's no, since there is no three-phase winding, so there is no requirement of an expert to design, to design those windings, to allocate those windings in different slots so that poles could be generated, equal that are required on stator could be generated. So there is no requirement of an expert for this thing. You can see very mass production of this thing could be done. These are the advantages of using squirrel cage. Why 90% of the three-phase induction motors are squirrel cage? Why 100%, almost 100% of single-phase induction motor are squirrel cage type? Rotor structure is of squirrel cage type. The major advantage is that in this squirrel cage type, the number of rotor poles will automatically adjust itself depending on the number of stator poles. Say, suppose our machine, if I'm using a squirrel cage type induction machine which is having 4 stator poles, then automatically this rotor structure will automatically develop 4 poles. If now these number of stator poles are reduced to say 2, then automatically this rotor structure will be reduced to 2. Means rotor poles will now carry 2 poles. If stator poles are 8, then rotor pole will be automatically 8. You don't have to do anything. Automatically, this structure, these now how is it done? How this rotor develops equal number of poles as those are present in stator? This thing we have already discussed while I was teaching you how the poles are being generated. How poles are being generated, different bars will be acting as north pole and south pole. Some bar will be acting as a return path, and some bar will be acting as a forward path. So there's no need to go into that design detail, but you just remember one thing which is very important, that automatically this rotor will automatically develop as many number of poles as many are present on the stator. So there is no difficulty, so there's no problem like equal number of poles should be present. It will automatically develop equal number of poles as are present on the stator. So this is the very big advantage. Also I have talked about advantage that it is maintenance free, since there is no slip ring and brush arrangement, and this is very strong structure, and you can produce these bars on bulk. Mass production of these things can be done, these types of rotors could be done. So this is another advantage of using such types of rotors. Slip ring induction motors appear since see this appear as a cage type. Now it is skewed. What do you mean by skewed? Skewed, will be discussing about skewed in the later half of this unit. Why do we need to do skewing? Now it contains a cylindrical core with thick lamination made up of silicon, steel, and semi-closed or closed slots which are skewed. Aluminum or copper bars are placed in these slots and permanently closed with end rings on both sides made up of same material. Okay, these all things are very. This construction is mechanically very strong, simple, simple design, less cost. Now this thing, see, I've marked important star mark. The poles are automatically formed on the rotor. It is flexible for any number of stator slots or stator poles. Okay, it cannot be started. Now the what is the disadvantage of it? This thing. It cannot be started with rated voltage applied across the stator. Therefore, it has low starting torque but excellent running condition. What am I talking about? See, in that slip ring induction motor, we have told that it could be started with rated voltage, but this squirrel cage induction motor could not be started. It is written it cannot be started with rated voltage. Why? Though it can be started, but there will be problem because of that. What problems are there? Voltage dip, and there are many problems. We'll be discussing about this when we study starting methods of an induction machine. But because if we apply such high rated voltage in these squirrel cage type, then a huge current will flow, and that will damage, that will do various disturbances. But in slip ring induction motor we can start with rated voltage, because when we even if we give rated voltage, but since we have added some external resistance in slip ring induction motor, so the starting current will be low. So that is why we are using that slip ring induction motor. In this case we need to have some different methods for starting. We cannot start it at rated voltage, especially large size motors. Small size motors we can start, but we'll discuss about all these things. But especially large types of motor we cannot start at rated voltage, because it will cause different problems. Voltage dip is one of that problem. We'll see. But it has very excellent running characteristics. See, because I've also told while we were discussing slip ring induction motor, I've told that once the motor has reached its approximately around its rated speed, then we'll disconnect those external resistance. And at running condition, both slip ring induction motor as well as squirrel cage both are one and the same thing. Means both have same running characteristics almost. So these are the two different types of machine. And you can ask one question, that's why you have written that we discussed previously that I've told you that yeah, this thing, that why almost 90% of the induction motors are three phase. Why IV means what was the reason for that thing? Because I was, as there are many reasons. I've already discussed that that there's no requirement of an expert for winding your machine, because since there is no three-phase winding in rotor, it's direct aluminum bars which need to be short circuited, and there's a straightforward structure. Maintenance is also very less. These are the reason. But when earlier when we were designing these induction machines now, we'll discuss that we know that the synchronous speed, the formula for synchronous speed is ns equal to 120 into f divided by p. This was the formula. I'll repeat myself that ns, formula for synchronous speed is ns, synchronous speed is equal to 120 into f divided by p. And in those days, if we want to control the speed of the induction machine, if you want to change the speed of the induction motor, then the only possible way is to change the number of poles. So if we use this slip ring and induction motor at those times, then if we change the number of poles of the stator, then again we have to redesign the rotor so that stator poles and rotor poles can become equal. So that was the problem while for using slip ring. But in the squirrel case, this was not the case. Even if we change the stator poles, the rotor poles will be automatically adjusted. So this was the advantage, because in those days changing the frequency was not that efficient. It was not that easier. But now with the advancement in the power electronics devices, we are able to change the frequency easily. we can easily change the frequency. So as I've told that what is the formula for synchronous speed? Ns equals to 120 into f divided by p. Now if I have to change or control the synchronous speed, I can also change the frequency. So now slip ring induction motor could be probably used more, you can say, in comparison to earlier days. So earlier days where frequency control was not that easier, so we use this 12 cage type of induction machine. So this is the reason this lecture basically covers about the what are the different types of induction machine, and we have talked about the constructional details. You can I'll send you this. I've already sent you this PDF to you, but I'll also share this PDF in on the Google Classroom. You can go and see this PDF. You can go through this PDF, and in case of any queries, you can ask me on that Google Classroom also. So you can go through these PDFs. All the complete notes are being provided that thing also, and I'll also be uploading this video on YouTube also. So you can go there and you can see that at that link also. So thank you very much. In the next class, we'll be deriving the expression, or we'll be, in fact, we'll draw the equivalent circuit of the induction machine, and then thereafter we'll be deriving the expression for torque, and then we'll correlate things. Okay, thank you very much.